Hi everyone, this lesson is on solving inequalities. We'll be using the graphing calculator throughout this lesson and start with the sample SAT question, which involves inequalities, and see how you do on it. Looking at example 1, solve and graph the solution on the number line. So we're going to start just by solving for x. So looking at this, we have negative, make sure my pen's working. Negative 5x plus 8 is less than 2x subtract 6 using distributive property. And then I will bring my x's together on one side by subtracting 2x. Negative 7x plus 8 is less than negative 6. Okay, let's subtract 8 over to the right. So negative 7x is less than negative 14. Just a reminder, when you divide by a negative, you're going to flip the inequality in the other direction. So x is greater than 2. So we will do parenthesis, we'll start at 2, and we'll go to infinity if we're going to write it in interval notation like we do in everything in this class. All right, as far as a number line goes for this problem, you would draw a number line. You would start at 2. If you're using interval notation, you can actually do a parenthesis at 2. And then it's everything in that direction, going to positive infinity. Example 2 is a compound inequality, and I like to keep everything together, and I'm trying to get x in the middle. So I started by subtracting 4 to everything, giving me negative 1 on the left side and positive 3 on the right side. In the middle, I'm left with negative 3 halves x. Now, when you multiply everything by negative 3 halves, or sorry, the reciprocal, negative 2/3. You'll multiply over here by negative 2/3 and over here by negative 2/3. When you do that, the inequalities are going to turn in the other direction. So they're going to flip. So now you have x, a negative times a negative is a positive. So positive 2/3, and then the 3's are going to cross cancel, and you end up with negative 2. Now, this is not the standard form of how we write a compound inequality, so we're just going to wrap everything around. Typically, we want the smaller number on the left-hand side. We see that x is greater than that negative 2, so it would look like that. And then x is less than or equal to the larger number, which is 2/3. So that's how you write the inequality. If we wanted to write it in interval notation, then interval notation would be parenthesis, negative 2, and we're going to go to 2/3, and we're going to have a bracket. So compound inequality is everything coming together. Looking at how this graph looks, we have a negative 2, and you would put an open circle, or if you're graphing as an interval notation, you could use parentheses and brackets, and then this is 2/3. So interval notation, it would look something like a parenthesis and then a bracket, and then it's everything in between. Now you could use a open circle instead of a parenthesis and a closed circle instead of the bracket. So looking at example 3, you can see that we have an absolute value which is less than a number. So if the absolute value is less than a number, then x is going to be in between the opposite of a and a. And so how we set this up is this, because it's less than, now it's going to be you take the opposite of a for this side, and now you have 2x subtract 1 is greater than negative 12 but less than 12. From there, it's a compound inequality. If it's going to be or, then usually it goes in opposite directions, but if it's an and, it usually comes together. So solving for x in the middle, 2x, you would add 4 to everything. So 12 plus 4 is 16, and negative 12 plus 4 is negative 8. Then divide everything by 2, and we have x in the middle. It is going to be greater than negative 4 and less than 8. So interval notation, this looks like parenthesis negative 4 until we get to 8 parenthesis. As far as the number line goes, that means that we are going from negative 4 to 8. You can use open circles or you can use parentheses, and we're looking at everything in between. So to verify, pick a number in between and see if it works. So looking at this, if I pick 0 is in between those. If I take 0 and plug it in, 2 times 0 is 0, and 0 subtract 4 is negative 4. And the absolute value of negative 4 is 4. And is 4 less than 12? Check. Yes, it is. So that's how you could check your solution. Example 4, I'm going to show you how you can do this algebraically as well as graphically. So this time we have the absolute value is greater than or equal to 7. And so the setup of this problem is different than the last because the distance is going further apart. So you have 2x subtract 3 is greater than or equal to 7, and you have 2x subtract 3 is less than or equal to negative 7. And if I scroll up, let's see if it will let me scroll up. If I scroll up, we are looking at this definition right here. And we end up with an or problem. So let's come back and look at this. So I'm going to go ahead and put the word or in the middle. So this is one or the other. Okay, so let's go ahead and solve algebraically. You would add the 3 over. 2x is greater than or equal to 10. Divide by the 2, and x is greater than or equal to 5. Or add the 3 over. 2x is less than or equal to negative 4. Divide by 2, and x is less than or equal to negative 2. So you can see graphically what this looks like. If you were to graph the absolute value of 2x subtract 3, all right? So here is your V graph. There's your absolute value graph right here. And then if you were to graph 7, so here's y equals 7. And we are looking for where it is greater than or equal to 7. So if you look at this number line, we see x is greater than or equal to 5, which is this part. Here's your greater than or equal to 5, or less than or equal to negative 2. So looking at where that absolute value is greater than or equal to 7 would be looking at this part of the graph and this part of the graph. That's everywhere greater than or equal to 7. So x, you can see this value is when x is less than or equal to negative 2. Or you can see this part over here when x is greater than or equal to 5. Example 5, we're going to practice using our sign charts again, which will also be helpful for calculus. So I have x squared plus 6x plus 8 is greater than 0. I started by factoring and solving for x. These are my critical values. So I have x equals -4 right here, and x equals -2, which is right here. So then what you do is you divide up your boundaries. So here's a boundary, here's a boundary, and you're looking for, if it's greater than 0, this case, we're going to be looking for the positive. So we want to know, where is it positive? Pick a number in this left boundary. You could pick something like -5. Pick a number in the middle boundary, maybe -3, and pick a number over here on the right side boundary. 0 is maybe a really nice number to pick. Now, when you're testing the numbers, you plug them in to the function, and then you determine if it's positive or negative. We are looking for the positives. So let's start with -5. If I take -5 and I square it, I add 6 times -5 plus 8. I'm trying to determine if that answer is positive or negative. So 25 subtract 30 plus 8 is barely going to be positive. So you can see any number that I plug in to the left of that -4 is going to come out positive. Now, the middle part, let's plug in -3. If you take -3 and square it, you add 6 times -3 plus 8. 9 subtract 18 plus 8 is going to end up being a negative solution. 0. If you take 0 and you plug it in for x, you have 0 squared plus 6 times 0 plus 8. That's a positive. So your solution, here are the positive numbers. Now, on this problem, it says greater than 0. So these values that were my initial points are not going to work. You do not want to include them because we only want greater than. So looking at here, let's look at our sign chart for our final solution. It would be -2, not including it, and everything this direction, and -4, not including it, everything that direction. So interval notation is going to give me a solution of -infinity until I get to -4, parenthesis, don't include it, and then -2 to infinity, parenthesis. And that is my solution to example 5. Example 6 is showing you how you could use your graphing calculator to graph the solution. So what you would do is you would take your calculator, go to y1, and just simply graph 2x squared subtract 5x subtract 2. It's a parabola. But because we have an inequality, we're looking for areas in the parabola that are less than 0. So you can see that we fall less than 0 in this area right in here. And so you would look at the zeros, and the first 0 is a -0.351 right here. And the second 0 is a 2.851. So in interval notation, we're not going to include the zeros, and it would be -0.351 to 2.851. All right. If you want to calculate those zeros on the graphing calculator after you graph it, you would go to second, and then you would go to trace, which is the calc key, second calculate. And then when you calculate the zeros, you're going to get these two as your answer. So here is how you can do this problem on the graphing calculator. I typed in 2x squared subtract 5x subtract 2 under y equals. Now what you can do is if you want your calculator to shade for you, you can actually arrow over to the slash line with the blue box and hit enter. Then you can come down to line, and if you hit the right arrow key, so here is the right arrow key, and you're going to right arrow. Now in this problem, the 0 is where the y goes, and so you want a greater than. So y is greater than, and then you have that quadratic equation. Now the greater than is the triangle in the upper box. If you want a less than, you would pick this triangle. So there's a less than, here's a greater than. Then you'll click OK, and it's going to zoom 6, gives us a nice standard window. It's going to graph that parabola for us, and it's going to shade. So you can see that we're looking for all those x values in between the zeros. So how do you calculate the zeros? You go to second, trace, and then you're going to pick number 2 for zeros. Then you're going to left arrow above that 0, hit enter. Right arrow below the 0, hit enter. This is your guess, enter, and your 0 is negative 0.351. You'll repeat that process. Second trace, go to 0, enter. And this time you're going to right arrow so that you're a little bit closer to the 0. Notice I'm left of the 0, enter. Right arrow so you're above the 0, hit enter. This is your guess, enter. And there's your 0 at 2.851. So you can go ahead, and we want all of the solutions. Notice it's below the x-axis in the middle there. So we want all of the x values between those two zeros. Example 7 is a projectile motion problem, and the formula is given. This is a formula you should really get to know. You use it in physics all of the time. And so let's look at this, and we have S, which is the position of the ball. So S is the position of the ball, is equal to negative 16 is gravity. And then we're looking for t squared. So this is the variable we're looking for, plus v sub o is the initial velocity. It says a ball is thrown straight up from the ground with an initial velocity of 59 feet per second. So this is your v sub o. So 59 t plus, and then S sub o is the initial height of the ball. So the initial height of the ball is 0. It's thrown from the ground. Now the question is, when will the ball's height above the ground be more than 30 feet? So we are looking for greater than 30. So on the graphing calculator, let's go back and let's turn off the inequality. So you arrow back over to that box, hit enter, come down to line, and if you want just a regular line, you're going to right arrow until we get that right there. And that's just your regular line. Okay, let's go to Y1, and how we're going to solve this on the calculator is first we're going to graph negative 16t squared, so negative 16x, and then a quick way to get this square is simply to hit this x squared key. So negative 16x squared plus 59, and then you have x. Under Y2, you're going to type in 30. All right? And then if you do a zoom 6, you're going to find that that is really not such a great window. So that doesn't give me the window that I need. So what I'm going to do instead is fix my window. So I'm going to go to Window, and I might go from 0, or you could even put -5. And the maximum, maybe you want to go to 5. And Y values, we're going to go from 0, maybe let's go up to 40 feet. And let's count by 5s. And then we can just hit trace and see what that window looks like. So there's my graph. And I don't like that I can't see the top of the parabola, so I might come back to Window, and I might change this to 50 feet and see what happens. And it still didn't quite make it. But what we're really interested in is we're interested in the parabola above that red line. So if you hit second, trace, and this time select intersection, which is number 5, then you're going to right arrow up by that intersection. Hit enter for the first curve, enter for the second curve, enter for the guess, and the intersection is at 0.609. So write that down because we're going to put that in our notes. 0.609. Then you're going to calculate the intersection again. Second, trace, go to intersection, and then you're going to arrow up and around by this other intersection. Enter for the first curve, enter for the second curve, enter for the guess, and the intersection is 3.078. And we're looking for X values in between those 2 points, because that's where the graph is greater than 30. And we're not going to include those critical values because it says greater than 30, not equal to. So go ahead and give the You Try a try all on your own. Then you also might want to just write a reflection on the lesson, and you should be done. Thanks so much. Keep this in your math notebook. So here's the You Try. You're going to take 2x squared subtract 7x subtract 30. You're going to set it equal to 0, and then you're just going to factor and solve. So I got -5/2 and 6. You're going to put those on a number line, and then you need to test values. So testing values, maybe this is -2.5. So maybe you're going to test -3, and I think I like a thicker pen. In the middle, maybe test 0. And then over on this side, maybe test 7. All right. And so you're going to test those numbers in this function. And when you do that, you're looking for numbers that are positive because this is greater than or equal to 0. So 2 times -3 squared subtract 7 times -3 subtract 30. -3 squared is 9, and 9 times 2 is 18. You're going to add 21 and then subtract 30. So 21 plus 18, that one's going to be really close, and it does end up positive. So this is positive. Plugging in 0 will be negative, and then plugging in a 7 will be positive again. So solving the inequality, I want positives. So my answer in interval notation is going to go from -infinity to -3. No, -5/2. And we're going to include the 5/2. Union. And then we're going to pick up at 6, include the 6, and go to infinity. So there you have it. There's our solution algebraically to the inequality.